Okay guys, today we're looking at factoring polynomials by grouping. So this is the what if we do if we don't have a greatest common factor, because again you should always be looking for that first, or a trinomial, and I should add one more thing, or a binomial, because we could potentially factor that by sum and difference of cubes. Okay, so what if we have a four-term polynomial? And it doesn't have a GCF, so there's no way to start there. And we can't use either difference of squares, we can't use splitting the middle, nothing like that because we don't have a trinomial. So hopefully you're not going to panic and cry, but what you could do is you could try factoring by grouping. Factoring by grouping is exactly what we do when we are doing difference of squares. That's exactly what you're doing. You're grouping pairs of terms together and you're factoring out the greatest common factor from each group separately. If the parentheses match, you're good. If your parentheses don't match, one of two things probably happen. One of three things, I guess. Either it can't be factored by factoring by grouping, that's definitely a possibility, or you could try reordering the terms and maybe trying again. To be honest, that doesn't work terribly often. And if not, you may have just simply done something wrong. Okay? But basically, this is just like we're in the middle of a splitting the middle term problem. So let's take a look at this first one. What I'm going to do is I'm going to group these two sets of terms and these two sets of terms. Okay? I'm going to factor out the greatest common factor from each. I get x and x plus 2. Here my GCF is a y, and I'm left with x plus 2. Hey, my parentheses match. Now I undo the distributive property, and bam, I have x plus y times x plus 2. Could go ahead and multiply it back out, it would work. One quick thing that I want to show you here, if I flip those middle two terms around and did x squared plus xy plus 2x plus 2y, and I tried factoring by grouping this way, I'm just going to go ahead and do it. I get x times x plus y plus 2 times x plus y. The parentheses match, and guess what? I get the exact same answer. So that's why I was telling you earlier, you could try reordering the terms and trying again, but oftentimes that doesn't work. Now, if maybe the first and the last term were, there's just so many ways you could have reordered these terms, and factoring by grouping would have worked in most configurations. But I guess, I don't know, maybe that's just me seeing the configurations that work. I don't know. But you can always retry and try again, but oftentimes you'll just end up being in the exact same spot. So here's what I want you to do. You guys know how to do this. You really do, because you're going to group the first two, group the last two. If you can get the parentheses to match, great. If you can't get the parentheses to match, it can't be done with factoring by grouping. The one caution I will give you is that after you're done with factoring by grouping, you need to make sure everything's factored completely. Okay? So try D, E, F right here, pause, and then come back. All right. I'm assuming you've done that by now. So here, 15 and 6 have a GCF of 3, and they both have an x, and I'm left with 5x minus 2a. Here, I have a choice. I could factor out either a 4c or a negative 4c. If I factor out a 4c, though, this is going to be positive and this is going to be negative. I need my first term to be positive, so I'm going to factor out a negative 4c. And I get 5x minus 2a. My parentheses match, so I can write 3x minus 4c times 5x minus 2a. Now check each of those individual parentheses. Can any of them be factored by maybe difference of squares, or is there a GCF in any of them? There's not, so I'm done. Okay, next one. Go a little faster this time. Taking out an x squared. Left with x minus 5. X minus 5. Take out a negative 9. I'm left with x plus 5. I tricked you a little bit, maybe. These parentheses don't match. Even if you change this to a plus, then both of these will be negative. There's no way to get those parentheses to match. you've got 3 negative terms and 1 positive term. Your terms are never going to be able to match. Let's pretend, though, for a second, because this is a very good example, that this was a plus 45. Try this, even if whether I fooled you or not, try this problem really quickly again, but assume it was a plus 45 there and take out the negative 9. Okay, I'm assuming you've kind of paused and done that. This would now be a minus 5, and we can keep going. We get x squared minus 9 times x minus 5. Check. Can any of those things be factored? Yes. X squared minus 9. X squared is a perfect square. 9 is a perfect square. I can factor that with difference of squares. I get x minus 3, x plus 3 times x minus 5. You do always need to look to factor further, especially when you're doing factoring by grouping. Last one, GCF of 3x in the first two. And I'm left with 5x minus 4. Take out a 2. I'm left with 5x minus 4. See, we could have combined those like terms, but it would have just become a splitting the middle term type of problem, in which case we would have gotten to right here anyway. We get 3x plus 2 times 5x minus 4. Neither of those things can be factored. Really quick, back to E. If this was the minus 45, you guys would just have to label that prime. Now, I'm not saying that, I'm not guaranteeing that polynomial is prime because there are other ways to factor it. You can't anyway prove that that's prime right now, I guess is what I should say. But we're not learning any other ways to factor that. There's going to be a few things that you will learn next year that'll help you factor polynomials like that without necessarily using grouping. But that is something for next year. That's it for this lesson. Hope you learned something.